All right, we're live. Great. Okay, well, welcome everybody. Thanks for joining, and thanks for joining online at home. Real quick, I'm just going to remind everybody that we are here as guests in the Microsoft Reactor, and we are gracious for them inviting us into this space. And we definitely appreciate the code of conduct. Microsoft is dedicated to empowering every person and every organization on the planet to achieve more, including the reactor. So everybody remain professional. We're not going to have any bias, discrimination, everything you're seeing on the screen. Please be welcome, respectful. We all come from different backgrounds and different places in our careers. So I won't read the entire thing to you, but I think we all get that, and that applies online as well. So I am Matt Johnson Pint. I do not work for Microsoft. I used to work for Microsoft, so this is nostalgic for me. So this is a lot of fun. I work for Sentry. We're going to talk about application monitoring in .NET. And I put modern.NET on here because I don't know what to call the new group of everything that is .NET and how .NET is written today. But I don't see, personally, .NET as legacy, right? There is, sure, it's been around a long time. There's .NET Framework stuff is still thriving and kicking. But I write in .NET 7, and I write mobile applications that run on iPhones. So I think this is a really exciting time to be a .NET developer. Let me tell you a little bit about Sentry real quick. So Sentry's been around about 10 years ish. We have support for 30 different languages. Probably the top one is JavaScript. We're huge in the JavaScript space, especially in the front end of the browser. We also are pretty big in Python. Our founder started out Sentry in Python. Sentry is an open source product. You can run it for free and host it and download it yourself on your own stuff. So everything I'm talking about here, you can do without paying anybody any money whatsoever. Or you can use a different product. This is not strictly about Sentry. We're going to cover application monitoring observability concepts. I'm going to use Sentry to demonstrate. And yeah, if you don't want to run it yourself, we absolutely have a SaaS managed product where we can run it for you. So let's get started here. The main topic of today is observability in applications. And this applies to any kind of application developer. I don't care what your programming language or background is. You are probably used to dealing with some of these things, or should be at least. So I like to think of observability in 4 different groups. Classic observability in applications usually is like system monitoring. Do I have enough CPU, RAM, storage, space? Are there enough nodes running? If I am looking at a graph of traffic spiking, I might need to scale up or scale out in order to handle that load, right? Think big rooms full of screens with charts and graphs and people monitoring to decide, how to run their network operations center. Systems monitoring is absolutely essential, and I don't want to deter anybody from using systems monitoring approaches in their applications. It is absolutely still important in a cloud world. Just because you don't have the physical hardware in front of you doesn't mean that systems monitoring isn't important. But it is a very ops-focused area, and so I'm going to leave it on the table and just say, okay, that's a thing, and it's not what we're talking about today. Really, your first foray as an app developer into observability probably starts off with logging. I've been writing apps for 25 years plus, and I can tell you that when I first started looking at this space, it was using things like Log4net that wrote a file to disk. I would say, instead of console write, I would say logger.log, and it would write off to a file onto the disk somewhere. And then what, right? Well, I got a lot of files, and I got to keep them rotating, or it's going to fill up the disk. And actually now I'm running on 10 servers, and how are they all going to come together? I needed the files from server number 3, not the files from this server. So logging is sort of like a first step. And in my view, it is an audit-focused task. It's a way to record what has happened so that later you can go back and find it. Now, there's a lot of great ways to bring logs together. We have log aggregators. There's stuff built into cloud services, AWS CloudWatch, Azure Monitor. All these have logging providers. There's open source stuff like Elma. And most serious applications are still going to need logging to a certain degree. So do be thinking about your logging strategy. But I can tell you this, if I'm trying to figure out what's going on in my application, like I want to make my application work great. Logs aren't going to help me do that, not really. Logs are going to help me find one thing that happened. So I can look and see, okay, what did that one thing do? But it's not really going to help me make my application great. So they are good for drilling into specific events, but sort of difficult to use proactively. I mean, I don't know, does anybody have logging in their application? And like, how often do you actually read your logs? Probably not very, yeah. Keep those hands raised, right? So we move more in towards the right, which these are the two topics that we're gonna be talking about today. We have application performance monitoring and we have error monitoring. And they are related, but slightly different. APM is what you do to record metrics of an application. So you can answer questions like, how many transactions per second did we process? How many widgets did we sell over this time period? And how long are things taking? You know, are those web requests running in 10 milliseconds or 500 milliseconds or 40 seconds where the user is sitting and waiting, right? And application monitoring leads into other spaces like distributed trace. And we're going to talk about distributed trace a little bit. And then taking it a step further, we really get into error monitoring, which is really the highlight of my experience as a developer, is that I want my apps to work. So when they don't work, I want to know why they're not working, and I want to know before my users are mad enough to call me, right? If I'm sure people have used any application, mobile, desktop, web, it doesn't matter, and something's broken, and you're like, I don't want to hit the error form. Like, they should know this already, right? Well, if you're doing error monitoring, hopefully they do know it already, and it's just baked into the application. That's one of the features of a product like Sentry or other error monitoring products. They tend to be very developer focused, so we are looking for runtime events. What's actually happening out there? When did something crash? What exceptions occurred in the application? Generally speaking, what problems are our users experiencing, and how can we fix them, right? And so to know how we can fix them, that gets into a really important point, which is we can't just have the exception and a stack trace. We need context around that. We need to know, what were they doing in the application at the time that they encountered this error? And all the little nitty-gritty details. What kind of device were they on? Were they on a web browser? Were they on a mobile phone? Were they on a phone that is like 6 versions of Android behind and has been rooted and is running some background virus thing, right? Like, we need to know those things because that might be the cause of the bug and not actually something with our own app. So capturing the context is a big deal. Then we have all this information, right? So what do we do with it? We need to aggregate it, and we need to prioritize it. So at the end of the day, I don't want to look at the same error over and over and over and over again. But what I do want to know is, there were 300 of this type of error and 2 of this type of error. Which one should I focus on first? Probably the one that has 300, right? And so aggregation and prioritization, or sometimes we just call it grouping, or sorting, however you want to think about that, is a really important concept with error monitoring. Once we do that, then we can do some interesting things. We can send alerts. So if you have an on-call cycle and you need to know when something's broken, you can set thresholds to say, if you're seeing errors of this type or in this area or something we've never seen before, that's an alert. You can raise an issue in your favorite issue tracker, on GitHub or on Jira or on anything, Azure DevOps, so that people can track these things better. We can do magic. It seems like magic, but what we can actually do is we can show you the source code of where that bug was, and we can try to guess when that bug was introduced. So we call that a suspect commit. Like, what was the actual thing that introduced this bug? And we can guess at that because we have a lot of data about what's happened in the application over time. And we can integrate with the source control system. And lastly, like we actually can do, I'm sure you've seen these things where something does go wrong, and you get a form that pops up and says, please tell us more about what you were doing. So we can do that. It's completely optional, right? But in this space in general, that's done a lot. So anytime you see that pop up, it's always a good feeling to me. Like even if I don't fill it out, they've probably got information about my bug anyway. And I really like applications that take this approach. I threw on the bottom here. Yes, it is incidental, but also once you start doing this, you can do some other magic by like knowing which releases are good and which releases are bad. If you're releasing constantly, that could be really important and help with things like rollbacks. So that's kind of the landscape, and we're going to talk about some of these things. I know this is a lot to sort of take in, but like this is observability in a nutshell. And it does get a lot more complicated, but it doesn't need to. Like if you can just sort of think these 4 categories, then like, you know, observability. Let's talk about, we're going to talk about the last 2, not all 4 of them. Let's talk about APM, performance monitoring. So this is a look of what performance monitoring looks like in Sentry. You can see that we have some graphs at the top that show us, and I love that it's called this in Sentry, is user misery. How upset were the users, right? And it's interesting, there is an actual calculation for that, like how upset should you be over something based on how often it's failing and how long things take versus how they normally behave. And there's some statistics that can be done to try to normalize this data so it's useful. And then basic stuff like transactions per minute, how many issues, what's improved. But when we look at the most important thing on here is the list of transactions. We can actually see here's all of the calls into our website where we are showing the different URLs being called, and we're showing the time that it took to run each one, right? But this isn't everything. This is like the things that are most important to be looking at. I don't necessarily need to see everything. I just need to see what I need to look at in order to make my app better. Once we pick a transaction, we can dig into it and see even more details. So I can say, okay, well, is this always running at 100 milliseconds? Or maybe there's, some standard bell curve here as far as like how the distribution of the performance of a particular transaction took. And maybe there's different types of spikes in that data depending upon when it was run. Sometimes you get more traffic on a weekend, sometimes it's more traffic during the week. All of these things, so we can sort of graph and chart to help us identify the things that we need to know in order to say, okay, there's something that's problematic with our application. Let's go fix it. And you can see down at the bottom here, we've got an issue that's related to the transactions that we're seeing here. So that gets a little bit more into the error monitoring and how error monitoring, performance monitoring can tie together. We'll continue. All right, as we're looking at the performance of an application, I use this term transaction. So what is a transaction? In Sentry's lingo, a transaction is an entire group of things that happened. So the user clicked a button and it started a process that did a thing and then came back and delivered a result to the user. So that would be a transaction end to end. In the example I'm showing you here, the transaction is an HTTP request, which happens to have an error. But that HTTP request is doing several other things. It's calling a database, and so it needs to connect to that database. Then it needs to run a query against that database. Then it's doing some other processing work of its own, right? And you can sort of see the breakdown here that this was quite a long transaction. It took over 3 seconds to complete this activity. So the user probably clicked the button and was like, this is slow. Most people want things that are, fairly rapid. And if I really dig in, I can see just from some of the data here, it looks like we spent most of our time trying to connect to the database. Now within this transaction, we have all of the other different things that happened, and we call those spans. Now other systems use the span terminology quite liberally and don't have this idea of a top-level transaction. So that is something that's unique to Sentry. So if you're using something that's more OpenTelemetry compliant, which I'll talk about OpenTelemetry in a minute, then you will not hear this transaction terminology. You'll just think of them as parent and child spans. But span is a nice word because it's the amount of time. It's a time span that something took to run, and that is important to track, especially when you can break down like, well, what percentage of that transaction was spent doing different things. If I'm spending 26% of the time to run this thing on actually just making a connection to the database, then there's probably an issue with either the code that is making that database connection not doing pooling correctly, or perhaps there's actually an operational problem with the database servers. But at least gives me the information I need to further investigate, right? Once we have this idea of transactions and spans, we can now do magic that we call distributed tracing. I love that everything is magic, actually. It feels like magic. It feels like I'm a magician working up here, but it's really not. Honestly, it's just recording what you're doing and making sure that it's captured somewhere. So a distributed trace just means we are stitching together multiple transactions. And how do we do that? Well, on the first one, we create a trace identifier. That's just this random unique identifier. And as we work with the next transaction, we pass that downstream and say that's the transaction identifier. And so everybody participates in the same, the transaction identifier, the same trace identifier. And everybody participates in the same trace. And so we can start doing some interesting things. The example down below, this is a game. This is a Unity game that calls a Google Cloud Function Server, and they're both written in .NET. And you can see that the trace started with the start of that game's round, and then it made this request off to a game server, and that took a very long time to return. So that created an error in that game. Now, if this was on the Sentry dashboard, you could like click on the little error, and it would drill in and show you the error. So we're gonna do that in a little bit. I'm gonna demo it for you. I mentioned OpenTelemetry a few minutes ago. Sentry is indeed working to work cooperatively with OpenTelemetry. OpenTelemetry is this open source, vendor neutral set of tools that are making their way into lots of different products. So the cool thing about .NET is we already have this long list of stuff already instrumented with OpenTelemetry in .NET. So if your web server is written in ASP.NET, ASP.NET Core, like all of the stuff that I just showed you about how do you collect those spans is already built in. So all we need to do is get it into your OpenTelemetry collector of choice. There are many of them out there. As of this exact moment, Sentry does support OpenTelemetry on a few of the SDKs, but not on the .NET one. So I'm working on that personally, and we'll have that very shortly. But in the meantime, we do have some of the support that you see here on our own without OpenTelemetry. So we have built into the .NET SDK for Sentry, we have ASP.NET and ASP.NET Core, HTTP client, SQL client, Entity Framework, gRPC. I'm just going down this list. We don't have Redis yet. We have some support for AWS and Azure Functions. We don't have Elasticsearch, Hangfire, Mass Transit, MySQL, Quartz, or WCF. So as we move towards OpenTelemetry, if you use any of these other things in your application, you won't need to wait for Sentry to go implement them. You'll just grab your OpenTelemetry library of choice, and everything will just work. Lots more I could talk about OpenTelemetry, but it is definitely the wave of the future, regardless of which APM platform you're going with. All right, I will wait for questions at the end, but if anybody has any in the meantime, I'm kind of running through these really fast. Are there any questions online at this moment? No? Okay. I got a question in the back, sure.
You talked about the APM. So what kind of latency does that collect the data?
It's a great question. What kind of latency is introduced into your application by collecting performance data so that you can actually do application performance monitoring? If I go back to this slide, for example, as I was connecting to the database, running these queries, processing these orders, how much additional time was spent because I was doing this monitoring, right? We would like that, and I'll only speak for my team, but I'm assuming that pretty much every APM vendor on the market feels the same way, is that we would like that to be as close to zero as possible. Now, nothing's ever completely free, but I believe that if the SDK that is collecting the data is written correctly, then it sort of works in the side on the background rather than getting in the way of the actual transaction. So for example, in the Sentry.net SDK, when we collect spans, which we collect all the time, we push them into a background queue, and then we process off of that background queue asynchronously. So they're not part of the transaction at all. And also, I think I might have mentioned the overhead view, but when you're doing this sort of performance monitoring, it becomes sort of useless to track every single transaction. Generally, you want to sample them. So we sample them both client side and server side. Sentry has a thing called dynamic sampling. But on the client side, we can also sample them and say, even though we're collecting them all the time, we're only going to send 10% of them, right? And we do that, all that calculation is done in the background. Does that answer your question? Yeah.
If your application is really performance critical, you can set up local instances of delay so that your connection is very fast.
Yeah.
Obviously, in front-end applications, all this data is only set up essentially transaction is complete, so the page is loaded, the critical already.
Yeah, I'll just repeat that for people online. Basically, it was saying that in Sentry, and I'm not sure about others, but we have this concept of a local relay. So you can actually install on your servers something that will receive that data locally. So instead of sending it off to Sentry, you can send it just to yourself and then have another background queue to go and send stuff off to Sentry on your own. And people do this often, not just for latency, but also to deal with things like CORS, cross-origin issues, and dealing with certain firewalls will block traffic. So like sometimes it can be beneficial to set up your own relay. And it's super easy. It's like a Docker container. You just run anywhere that you want to, and it works. So I will dig into, you have another question?
I was going to say, it's sort of
Sorry.
related to that. My experience with telemetry this way. There's always two scenarios you want. There's the, I want to control the dial dynamically, and right, I only want to turn the spigot even on or all the way up when something interesting happens, right? So maybe I have something very low, like I don't need to be collecting on this level of detail for transactions happening. However, if I happen to just track, let's say, connection time, and then I see it goes, it's taking longer than normal, that's when I want to turn the dial up and see more.
Right.
I don't want to redeploy. I don't want to. It's already out.
Right.
So that would be scenario one. Scenario two is something actually goes wrong. I don't want to collect all the details just so I can find out everything all the time. It's
right.
a sliding window, right? If something goes wrong, show me things that I was doing for like the last 60 seconds.
Yeah. So the scenarios you're describing, where and I'll try to summarize. You know, if you're collecting data all the time, that's a lot of data. But maybe you do need to collect all the data sometimes, or for a particular part of your application, perhaps. Not everything is equal when it comes to this sort of stuff in terms of trying to figure out what is valuable data to you. And so both from the overhead in sending it and for any costs involved, then you definitely want to be thinking about how do you scale up and down in that regard. For some applications that does require redeployment, if you're sampling client side or filtering client side, then yeah, that can require you to say, oh, I'm going to need more data, so I got to redeploy. Well, the last thing you want to do in the middle of like a big spike of data is a deployment, right? So or a big spike of traffic. So Sentry has this feature called dynamic sampling that addresses that head on, where basically you send all of your data to your relay or to us, and we apply your transactional rules there, where you can configure them on the fly. So that is something that we have built in, and I think. Again, speaking in general, like that concept is something you may or may not find in all providers that do this sort of thing, but it is something that we offer in Sentry. I'm going to move along to just the last phase of this little 4-stage thing, because there's still a lot more to talk about. And let's talk about error monitoring in general, because like up to now we've been talking about performance monitoring, right? And like observability in general. But like I get super excited about error monitoring. For me, it all comes down to issues, because I don't like to hunt and peck my way through the system trying to figure out, well, that thing is slow or this thing got a 500. So like, what is actually broken? Please show me what's actually broken. And error monitoring is designed for that. So what you're looking at here is the issues dashboard in Sentry, and you can see that like it's sorted roughly by the things that I need to look at. And because they're issues, I can do interesting things like I can dismiss them. I can say, you know what, I know that happens, but it's actually not a problem, or it's something we're working on and not going to get to right now, so please stop alerting me. And you can click the button and dismiss it. And even if more are coming in that are exactly the same, you're not going to get more. So the fingerprint of a specific bug gets aggregated with other bugs of that type, if that makes sense. So you're not getting every instance of every bug, but I'm seeing here there's 254 of this syntax error that I need to go look at right now. And if I don't want to look at it right now, I don't need to, right? I can also assign this to somebody and say, okay, this is this person's responsibility to work for, and that really helps with keeping track of things. And I can see how often does this thing happen, and this is where we get into like, it only happens on Friday nights at 2 a.m., right? Or maybe it's happening constantly. Or maybe we have a whole bunch of them, but then we saw nothing, and then all of a sudden we're seeing it again, so it might be a regression. So I can track those things separately in that way. Also, just at a glance here, I can see that I've got this one that has this unhandled thing on there, which means that it actually escaped the application, hit a top-level error handler, or crashed the application entirely. And so those are probably things I need to look at sooner than later. You know, it's going to be very different depending on what you're monitoring, but ideally it should have all of the data that I need to actually debug and investigate this without picking anything else up. So once I have that list, and I know this is a lot to squeeze onto one slide, but you can kind of glance at it, and I'll zoom in on a few things. What do you get, right? So a good error monitoring solution should track for you a stack trace. Absolutely should tell you it was in this line of code, and this line of code, and this line of code, and the error occurred on this line number, right? That is something that you should have in an error monitoring solution. It should also give you the ability to say, okay, what version of everything was it on? What version of .NET? What version of, in this case, this is an iOS app running iOS 16.1 on an iPhone SE 2nd generation ARM64 device, running .NET 7, and it's been tagged with all the information I need to know, release 1.0 of my application, and I can correlate all those things back to like, okay, well, where is it actually happening? Is it only happening for some subset of users or for other subset of users? Because I can tell you as a developer, I do spend a lot of time, and I have throughout my entire career, trying to reproduce a bug that somebody says is broken for me, and I like, works fine for me. It works on my box, and then you're done. But like, when you say works on my box, are you the outlier? You know, it works on your box because you're the one developing the product, and maybe you forgot that you installed this other thing that's actually keeping the bug from happening, right? And if you see that there's hundreds of other people out there that are hitting this bug, well, then works on my box isn't good enough. You need to know what's that subset of people. Just kind of going through this again, and there's a lot that we can see here. I'm actually going to pull open the Sentry dashboard here in a little bit, so we'll just kind of glance over this. But we have this idea of breadcrumbs, right? So a breadcrumb is a really interesting thing. I was talking earlier about logging. Well, what do you do with logging in an error monitoring world? When do I want to look at my logs? When there's a problem. So what we do with logs is we convert them to breadcrumbs. So what were all the logs leading up to that error? This thing worked correctly. This thing worked correctly. This thing worked correctly, and then the error happened. So maybe the user navigated through a particular path in the website. Maybe they slid right and got a pop-out panel on their phone, and then they clicked the button, and that all worked fine, but then they clicked another button and it crashed, right? So we would have that sequence to know that it's not just when they click the button it crashes, it's when they went through that path that it crashes, which is also really important. This particular screen capture does a poor job, but down the right-hand side, we can actually get a, because this is all 100%, so it just looks like bars, but if we had subsets of users experiencing this bug, this would highlight here, because we would see that the issue I'm looking at is in iOS 16, but that's only 40% of the users experiencing this bug, and actually the other 60% of them are in other versions that aren't experiencing the bug, which can be really useful information. All of this, and I can keep waving my hands here, but all of this just comes down to like, error monitoring is about capturing context. Oh, here's the zoom in. I forgot I had the zoom in one here. This is just what I was showing earlier. Stack trace and breadcrumbs, right? They work together. So in this particular case, let me just kind of go through it here. There was a null reference exception. I think every .NET developer has had a null reference exception at one point in their life. We just call them NREs. I've learned to call them NREs anyway. And in this particular service, let's see, there was something in an app called greeting service. It says say hello, but when I clicked the button to say hello, it threw an NRE, right? Well, what happened leading up to there? So it looks like there was a page appearing, and then a window was created, and then a button was clicked. The button was called hello button, and then I got the NRE. And the nice thing about that also is I can see the timeline of that thing happening. So if these things are coming in, like in this case, there's a 2-second gap between when the window was activated and when the button was clicked. So I know that there's a delay in here that was the user's actual delay, right? Like the application didn't hit the button automatically. The user looked at the screen for 2 seconds and then clicked the button. And that can matter, because if you're dealing with like background threads doing things, right? Well, maybe sometimes they click the button, everything works. So having the timeline is super helpful. What else can we capture? Gosh, there's so many things you can capture, especially on a mobile device. I just got into mobile programming recently. I was always back in client server or cloud or web servers, and I am loving mobile world now, especially with .NET MAUI. MAUI is got my thumbs up, at least at this point. But wow, we can capture a lot of stuff. So we can know, like I said earlier, what specific version of Android, what device it was running, what the screen resolution is. Like a lot of bugs are actually layout bugs, and they may not exhibit the same bug if your device is rotated in landscape mode than when it's forward, and so that matters. We can tell. In this case, I was running the application on a simulator. I wasn't actually on a real device. But if I was on a real device, then like how would you know the difference otherwise just from looking at a log? You need this information collected. It also tells me how much memory was available, how much disk space was available, what other .NET assemblies were loaded, which is really fascinating when you think about modern .NET programming. It's all Lego bricks all put together, and maybe the bug is because you're using a specific version of some library, or you're using a version of that library. You don't even know you have the library because you're using something else that depends on it transitively. And having the list of assemblies in there, then like it can really help say, oh, I'm having that bug because some version of Matt Johnson's time zone picker library that I'm using in my code has that bug, right? Well, now you know. I did mention on the overview slide that we can tie this back to who introduced the bug. This is something that is coming to .NET, but Sentry has it for a lot of the other APIs, so like it's coming to .NET real soon. Engineering work needs to be done. But basically what you do is you tie Sentry to your source control, whether that's GitHub or Azure DevOps or GitLab or whatever. We have integrations for all the major providers. And as it starts noticing versions of how things are actually being deployed and the timestamps of when they're being deployed, and then the bugs coming in, as not just the bugs, but also we do something called a session. So when you start an application, you can just say, hey, I'm alive. I'm version number 3 and I'm alive. That's all you have to say. The application can do that and start it very rapidly. And so we can keep track of, well, these are the ones that are working well, and these are the ones that had errors. And by doing some math, you can say, okay, well, the last commit when this release came in that was working on something in this area with this kind of code, probably related to that particular commit. And then you can very easily assign it to that person so they can fix it, right? At the end of the day, what we want to do is fix the bugs. Let's move to the next slide. I want to show you another feature that is coming soon for .NET because Sentry is very full-featured. But I was telling you earlier that everybody should show you a stack trace. Well, we do, but I would also like to show you what we call source context, which is here's all the code, the exact code of your application, and the line of code highlighted. That it was the line creating the error. It's almost like you're in the IDE. But you're not an IDE. That code is running on some user's device on the other side of the world, right? We can even show you, different values that were in variables that are used in that code with a little bit of analysis. This is Python code you're looking at here. We have this feature in Python and JavaScript and a whole bunch of other SDKs, and it'll be in .NET soon. What we do have is what I was talking about earlier is release health. So release health is, all right, what you're looking at here is a Unity game that had went through 3 different versions, 3.0, 3.1, and 3.2. And it looks like the current version, 3.2, is got a 95% crash-free rate. And the one before it had a 99.796 crash-free rate. So there's some bugs in here. I've got 308 crashes of that version. So if I was looking at this and it had just happened, probably the first thing I would want to do, well, I'd probably look at the bug first to see if it was simple, but probably I would roll back. I would say whatever it was that we did in that release, I would roll back because the last release before it was safer. Now in a game or a mobile app or something like that, the way you roll back is you revert the commits of that and then push forward. So because you can never really have somebody uninstall their game, you just put out another update. But the concept still applies. That makes sense. All right, so that was APM. Now what we're going to do is we're going to apply this to all this stuff. How long you guys got? Let's go through every single application type that's on here. No, I'm just kidding. This is what we do in .NET, though. This is, when I say modern .NET, this is what I mean. And notice it's not all Microsoft. We've got Avalonia and Uno and Godot and Stride and Unity. Like, the world is expanding. AWS Lambda is a great place to run .NET. Google Cloud Functions is another place you can run .NET. Obviously Azure and Microsoft and all that, but the world is much bigger than just our little island. And indeed, I can now effectively write native code for Mac OS. Did you guys know that? So most people don't know this. So okay, this is completely not what I was planning on talking about, but we'll talk about it. .NET MAUI is a wonderful new thing, multi-application UI platform, I think is what it is. And out of the box with .NET MAUI, you get iOS, Android, Windows through WinUI 3, and Mac OS through Mac Catalyst, which is an Apple technology that lets you run iPad and iPhone apps on your Mac as if they were native. And then there's this add-on for MAUI that lets you support Tizen, which is Samsung's platform for mobile devices and televisions. But Xamarin is not gone. So I don't work for Microsoft, so I can say that. Xamarin is still alive and kicking. Xamarin is actually the base layer for MAUI. Anything that is MAUI is actually a Xamarin app. It's not a Xamarin Forms app anymore. Xamarin Forms has evolved into MAUI. But the MAUI iOS target uses all the source code for that is on GitHub in Xamarin.Mac iOS. That's where it runs. And you can write an iOS for .NET app without MAUI. I Maui team probably wouldn't let me saying that, but it is true. You can say file new iOS project. You can just literally say .NET new iOS, and you'll have an iOS project with no Maui in it. It's a Xamarin app, and it uses the modern .NET 7-iOS targets. And so some of those have made their way into Maui, and we can write for them with Maui, or we can write for them on their side, and you can use Sentry with any of those. But there are other platforms that you can write for with Xamarin that aren't part of Maui, and one of them is macOS. So you can say .NET New, I think it's .NET New OS X, and you get a macOS application that is all in C#. And it's just a wonderful time to be living in, because like previously I would have to really be an Xcode developer to make any progress on such an application. Don't have to do that anymore. Yeah, the experience is a lot better in Maui, so a lot of people are going that route. But that's just my opinion. Okay, I'll come back to the deck here. I don't cut Xamarin off of the list of things, because it's definitely still something that is involved in the ecosystem. It's just evolved along with it. But yeah, so that's sort of in the mobile and desktop space, right? Like I can write a Maui app that runs as a Windows desktop app. But what if people have been running for years on Windows desktop? I would gather that the largest technology adoption for Windows desktop these days is probably still Windows Presentation Foundation, WPF. WPF's been around a long time. It's a great technology. It's not going anywhere. It runs great on modern.NET. There are upgrade paths to get you off of .NET Framework and into .NET and stay on WPF, and it is great. A lot of WPF applications out there. There are still Windows Forms apps that run on modern.NET. There are older things that are not really part of .NET, but still use C#, and so they're sort of paired with .NET, which would be like UWP, or used to be called WinRT. So if you are writing a native Windows application, you might want to be in that space, but that space has evolved into this thing called WinUI. Now I don't work on those teams, but my understanding is that UWP is basically WinUI 2, and modern space is WinUI 3. I got a head nodding from the audience, so thank you. And WinUI 3 is the Maui target for Windows. So if you write for Maui and you deploy to as a Windows, like in the App Store, native Windows application, it is running WinUI 3. So it is part of this ecosystem also. And then like let's not forget our clunky little console apps. Like you may be just writing Hello World with a console app, but like I've seen some pretty great CLI command line tools written in .NET. The .NET command itself is a great example. There's also a whole ecosystem of console app developers using projects from a library called Spectre. So you can get colored graphics and drop downs and menus, and it looks like a full-featured application, but it's all ASCII, right? It's all console, and they're cross-platform. So you can write cross-platform, colorful, interactive console applications in .NET and then run them on Linux in your favorite Docker container, or whatever, however you want to run that. Or you can run them in WSL on Windows. Like there's no end to any of this stuff, and .NET is there for the whole way. And you will definitely want to monitor those types of applications. Just because it's a console app doesn't mean it doesn't need any sort of monitoring. Some of them don't. It depends on what it's doing, right? But certainly having telemetry about an application will help you find and fix your bugs, even if it's just a little console app. We have these other two platforms, Uno and Avalonia, which are sort of in the same space as Maui, in that they are used to create code once and run multiple places type things. I love both of them. Sentry doesn't have direct integration for these yet, but like you still can use it. It's just you're kind of on your own for wiring it up. With Maui, we do a lot of the legwork for you. So, gosh, what else is on here? Okay, over on the web side, we got Blazor. Like Blazor is really cool. I can now write C# that gets compiled to WebAssembly and runs in the browser. It just blows my mind that you can even do that anymore. And if you don't want to run it in the browser, you can run it on the server. And there's like write once, run anywhere kind of place. You can even run a Blazor application within a Maui application on a mobile app. So these these worlds are all colliding, I think is what the gist of it is here. And as a .NET developer nowadays versus say 10 years ago, 10 years ago I was writing Windows Forms and ASP.NET Framework, right? That's what I did as a .NET developer, and the world is just so much bigger now. So let's kind of pick through some of these. I think I mentioned, but what I want to talk about in each one of these things is like, with regard to APM, what should you be thinking about? Right. So if I'm writing web apps, what do I need to be thinking about for APM and error monitoring? Because it's not necessarily everything that you would expect. Yes, in the browser. Okay, let's just put ourselves in the browsers for a little bit. Sentry has an awesome JavaScript SDK for the browser, and there are others as well. But you'll definitely want to capture any errors. That's kind of a given. Like instead of just console log out to the F12 menu where nobody can see it, you actually want it set somewhere. But beyond that, like it'd be really good to be able to track how your app is behaving. So there's this general concept, it's not a Sentry concept, called Web Vitals, where you would track like how long does it take to render different components of my application. What was the response time from when that page was returned from the server and when the actual HTML appeared? Were there delays between when the text box appeared on the screen and when the user could start typing in it? I'm sure we've all had that experience. You go to search and like you're in it, but you're not quite in it yet. So there's an input delay there. There's a lot of other little metrics that have been sort of best practice standardized around that you really would like your APM tools to pick up on so that you can improve your front end code. Front end code is every bit as important, if not more so, than the back end code, in my opinion. Definitely you need to be thinking about your outgoing HTTP requests. That's kind of what the browsers do. When you do that, ideally they would have a trace header as part of their request so that you could participate in the whole distributed trace story. User makes a request that starts a transaction on the back end that calls a database, that calls another thing, that calls another thing. And if something happens 10 layers down, you want to know that it was related to the user clicking that button. This is another space where having open standards like OpenTelemetry really helps. Also having multiple language support in the same platform really helps. So I think I mentioned it a few times, but Sentry is like the largest provider of this in the JavaScript space, but not necessarily so much in .NET. So it turns out that if you're running Sentry in JavaScript and in .NET, that it all just sort of works magically. How about that? But the same could be said for, say, application insights, which is definitely a space that Microsoft developers are familiar with. If you're running App Insights in the browser and App Insights on your server, you can do your distributed traces using App Insights under Azure Monitor. Let's talk about the server side of it. Again, we're a .NET audience here, so we're thinking about exceptions. Now, ASP.NET Core has built into it a exception error page that you can modify or manipulate, whatever. There's a generalized exception handler. That's normally where you want to hook things. But also, a lot of code does just try catch. And if you catch your exception and then don't do anything with it, maybe you literally do nothing with it, you just follow it so nobody sees it everywhere, then you don't know that it failed. You just don't get an error, and it's like, you know, I'm not going to hear it. So a real like simple thing you can do if you've got try catch is in the catch you can say capture that exception, please, my APM provider of choice, like Sentry, and that's all you have to do. Then you know at least it's happening. Definitely the server is responsible for capturing the incoming HTTP request. That's what it's there for. But a lot of people forget about, well, outgoing HTTP requests. So in the .NET space, I would use an HTTP client. And in modern .NET, I have this thing called HTTP Client Factory. I can register an HTTP Client Factory by default in ASP.NET Core, and I can just ask for an HTTP client. I can say, okay, well, my web server is dependent on this other microservice. And so when I get a call, I'm going to go make another call, and it's going to come back and go forward again, right? Well, all of that is part of that same distributed trace and really should be transacted end to end. So it's important that you're instrumenting your outbound HTTP requests also, and passing along any of the appropriate trace headers that are coming in off of your first request into those outbound requests. In the Sentry.NET SDK, we do that for you. If you are using HTTP Client Factory, it's already done automatically. You just use it and it works. But you can always ask for it yourself. There's HTTP Client has this concept of a message handler, and you can use the Sentry message handler, or you can write your own to do that work. The other thing a server is commonly doing is making a call to a database. In .NET, most of my career in .NET was working with SQL Server. So I would have a SQL Server that I would connect to, get a web request, make a call to the SQL Server, get back the web request, and go on my way, right? Might not be SQL, though. It might be Postgres. It might be a database, document database type product. It might be a distributed cache like Redis. It might be any number of things, right? And all of those types of client calls should be instrumented so that they can appear as part of the distributed trace story, so that you can help troubleshoot when things aren't working right. And then the last thing I want to throw on there is just retries. And people might be scratching their head and like, why do I need to instrument retries? Like, okay, well, a lot of code, especially in the cloud, will encourage you to like, well, if it fails the first time, try again. Or they might do like what's called a back-off exponential delay. You can, in .NET, there's this library that's wonderful called Poly that'll let you very easily wrap a call to something and then repeat it with different patterns. So you can say, I want to repeat it 3 times, but the first time I want a 30-second, or the first time I want like a 1 second back off, and then I want a 5 second back off, and then I want a 10-second back off, and then I want to fail, right? You can do that. Or you can just write it yourself in a for loop. But my point is, if it is working on try number 7, there's probably something still wrong, and you've got latency that you don't know why that's happening. So if you instrument your retries with nothing more than a breadcrumb saying, I'm retrying, in Sentry, you'd say Sentry SDK.capture message, retry number 3, whatever, retry number n, and it would just log it as a breadcrumb. So the nice thing about that is when you go back and look at your errors when they do happen, or your transactions when they are slow, you can look at the breadcrumbs list and say, oh, it's because I spent all my time retrying that connection until finally I got through it. So that's something to think about. Let's go into that client app space now. I'm going to kind of merge several things here because most of these are the same, regardless of whether you're talking about a mobile app or a desktop app or a console app or even a game. This new world, I'm going to think about it from a mobile apps perspective, but most of these things apply also for desktop apps. The main thing, again, you want to capture are your exceptions. So in .NET, when we think about exceptions, we think about managed exceptions, right? So this is coming from C# or F# or VB.NET, or one of the other flavors of .NET languages that there are. You might be running PeachPy. That'd be interesting. But you can run other .NET languages and get .NET exceptions. But we have this thing called ahead of time compilation, which turns .NET code into native code. And we have, in the game world, we have in Unity, they have this thing called IL2 CPP. So it is converting your .NET code into intermediate language into C++ code. And even if you didn't have all of that, so you're running on Android and you're going through Xamarin, well, it's C# in one place, but then that's Java underneath. And that Java actually might be invoking some native C code. So yes, it's .NET exceptions, but in environments where you've got a more complex infrastructure, device infrastructure, then you also need to be thinking about native crashes. Because if you have an application, for example, you have a iPhone application that crashes at a native layer to where you get an iOS crash report, the only thing it's going to do is send to your app store a +1 with this very cryptic stack trace. And you're not going to see that data light up in your APM provider if you're not capturing native exceptions. Now, the nice thing about the Sentry SDK, sorry to keep harping on my home territory, but we do have in our MAUI SDK, we embed our iOS SDK for iOS devices, and we embed our Java SDK for Java devices, and you don't even have to worry about any of that. It just all works. So for a .NET developer, they're just like, all right, I just run it, and then whenever it fails, regardless of where it failed from, that comes through into my application. We do the same thing in the game environment with our Unity SDK. Games do have to think about a few other things, though. If you can imagine playing a game that is scripted out in C# and that script is running for, I don't know, every time that a character like pulls a trigger on a weapon or picks an item out of inventory or whatever it is, there's the idea that like there could be a very high degree of events happening with the same error, like 1,000 errors in like 10 milliseconds, right? So debouncing becomes important. Debouncing is what happens when you like hold your keyboard down and then you're like, no, I want every fifth event. So it's not exactly the same as sampling, but it is something that in gaming especially, we want to make sure that we're only sending you enough information to know that there were errors, not every single occurrence of that error. And there's just some unique things you have to think about in games where errors could happen. See unload and unload is a big one. On mobile devices, besides just your normal stuff, sometimes mobile apps hang. I'm sure you guys have experienced that on various applications. You pull open your app and it's just hang. We call that an ANR, application not responding. At least they call that on Android. I think it's sort of a universal term. I'm not positive. That can happen on desktop apps too, but it's very common on mobile. On desktop apps, it's less common for .NET these days because usually that was something that you saw in the native world with older, before .NET, if you're dealing with MFC applications in C++, for example. But for .NET developers, we don't really see a lot of ANR type behavior anymore because of everything being managed code. But a lot of stuff on mobile is native, even if you write it in C#. So that's the important thing to remember there. Let's talk about connectivity for a second. I know I'm kind of working up backwards from this list on this slide. What do you do if you're on your phone at 3,000 feet on an airplane when your application crashes? What is the app going to do? You can't send it to Sentry. You're not online, right? You're in airplane mode. Or what happens if you're using there's background apps running on this thing all the time, right? Like there's notifications. I might be driving down the road using a GPS software, and if that thing has an error, they've got to get out somehow. Now maybe I have mobile connectivity, maybe I don't. Maybe I'm in a blind spot where I don't have the data, so it looks like I'm online, but you go try to send it and everything's failing, right? So it becomes very important, especially in mobile, but again, for everything, to have some capability to store and forward. So ideally what you would have happen is the application writes the error to local storage somewhere, and next time there's connectivity, it's sent. Now, it's a very simple concept to say, but in practice, it can be quite complicated. And so this is where you get into the real value of having an error monitoring solution where this is built into the SDK. And yeah, it's just something you have to think about. You're not always online. So if you're in the cloud, you're always in the cloud. You can always send stuff upstream. But if you're on a client app, not necessarily. I think we talked about the rest of these stuff. Just one last thing. Sometimes transactions are hard to think about on a client device. On a web device, it's really easy to think about. It's the web request came in and the web response went out. So that's a transaction, right? Or span, you think about that. On a client app, my rule of thumb anyway is it's from the user action, like I clicked a button, all the way through to when they're back to the next spot where you're waiting for the user. The result was displayed. So if that involves you clicked a button and then there's a web request sent and then a response received and then some stuff rendered, that's all one transaction. Yeah. So maybe I didn't say this earlier. Why is it important that you understand what the transaction boundaries are? It's important because while you would like everything to be auto-instrumented, nothing's perfect, for one, and you're the application developer. You're writing these apps. You know what your app does. And if you don't say, this is the thing I want to track, you don't say start and end in your code in the right spots, then that won't be tracked, right? There's only so much you can do automatically. And even if it is tracked, it's not necessarily going to have the context that you know what's happening. Like you may know that when that button's clicked, that means somebody's paycheck is written, right? I don't know that. I only know a button was clicked. So context is important here, and this is why app developers have to be thinking about these things. Backend applications. Okay, yeah, again, we have to capture exceptions. You don't really have to think about native crashes in a backend.NET world. It's pretty much all managed. You do need to think about other types of incoming requests depending upon what your app does. If it is just ASP.NET, that's probably fine, but you might still be writing a Windows service or a background worker now. You can run background workers as a Windows service. But maybe you're doing some cool stuff with telephony. Maybe you are connecting to an IoT device that is opening and closing your garage. I don't know what you're doing with your backend stuff, but it's not all straight HTTP. Also, a lot of microservice architecture depends on sending messages to queues. So if what your backend does is it receives a request and then writes out to the queue, then the write out to the queue would be one thing that you should be instrumenting. And if your background worker service is sitting there listening to a queue as a handler, then that it received a message off the queue is another thing that needs to be instrumented, right? Along with, did it successfully process it, or did it send it back onto an error queue or a dead letter queue? Anything that you might be doing needs to be instrumented, basically. I think I mentioned earlier, but like distributed cache is used a lot on backends. The main thing that I think is different that I will call out is serverless. So Azure Functions, AWS Lambda, GCP, Cloud Functions, and Google. For .NET developers, we do a lot of stuff on initialization. We set up dependency injection. We connect to various providers. We pre-initialize stuff. And that happens every time there's a cold start. So a big challenge with serverless is trying to reduce or eliminate cold starts, which is beyond the scope of this topic, or this talk. But it is something that you would want to instrument. You would want to say, all right, I don't, like, if it wasn't serverless, I might not start monitoring until after my app was fully up and running. But if it's serverless, I'm going to want to monitor the initialization time also, because I want to know that the user sat there waiting for an additional 300 milliseconds before I could even handle their request. And then lastly, with serverless, there's also another challenge, which is that most functions providers want to shut down the function as soon as the response is sent. And I was telling you earlier about, well, the best thing you can do to not get in the way of, like, how much overhead does it add to your pipeline? The best thing you can do is store it in the background and not send it as part of the request, right? Well, one way to keep it alive is to swap that and say, no, I'm going to send off the request to Sentry or whoever my provider is before I return to the user. Well, that would slow everything down and not be great. Another thing you can do is you can say, I'm going to send the response to the user, but I'm going to flush completely my processing queue before I terminate the actual function call. And to do that, you have to really understand how that function is written and managed within your serverless environment, because there are timeouts. If you can do it in a second or two, you're probably fine. But if it takes longer than that, you're probably going to get shut down while you're trying to send off the information that's valuable. We have some of these challenges in just authoring the Sentry plugins for these environments. So it is worth bringing up, because you'll probably have them in your own code as well. That is as much talk as I have. I think we have time for demo. We have time for questions. Let's have some questions. Yeah.
So you talked about the Face ID, right? That just use it.
Yeah.
And then, so basically, if I understand that right, so you could technically do the client side, middleware, server side, everything at common.
Yes, if you have the client side, server side, middleware, everything can come together as one trace ID with separate transactions within them.
So if you are waiting for things to happen, how real time can you do it?
If I'm waiting for things to happen asynchronously, how real time can I get? So certainly the errors that you would show in any APM tool are eventually consistent. You can be thinking about them in near real time, but not in real time. There's always going to be a transmission delay in between the time that the errors happened and the time you're receiving them. There should be, because it's not the job of your error monitoring or APM solution to be live connected to your application. That would create some dependencies and some other network overhead that would probably slow your stuff down, especially if you're offline, right?
So if you're trying to build sort of automation around the production, any kind of let's say I'm having a bunch of problems with the server instance. What are
I think I understand your question, but maybe we could pass the mic over so you can ask it again. I don't want to have to repeat every word.
No, what I was asking is if you want to build.
Yeah, it's on.
Okay. So if you want to build, like, let's say I got the error, but if I want to take some action depending on what threshold I set there for the errors I'm getting or I'm receiving from Sentry. So if it is not if it is not real time, how do I do that? How do I build those automations? So basically,
it would be close enough to say, like, hey, I get an error in Sentry and I need to send a page, right?
Yeah.
So yeah, you're right. There's some time to mitigation, right? Like, because you don't know that like a one error happened, and oh, that's something I should alert on right away. Maybe the error happened on a device that was offline, right? So you don't necessarily know about it until the device comes back online, which could be any amount of time, hours even, right? And maybe they're offline, but they're not running your app anymore. They've suspended it, so you have to wait until they come back into your app again. So maybe you don't find about the problem until the next day. I would say the answer to that is you get as close as you can, depending on the scenario that's offered, and there really isn't a magic bullet there. In a situation like a live web server that is processing thousands of requests, and you may be pretty near real time connected up to your Sentry Relay or to Sentry directly or whatever APM you're choosing. I was running through App Insights the other day, and they have the exact same problem. You can throw an exception, and then you sit and wait for a little bit, and then the exception pops up, right? So that's just the nature of how this thing sort of works. You can build things around it, but you just can't have the expectation that it's done in real time. Now, if you didn't have it at all, then your time to mitigation is even higher.
Yeah.
So at least with some degree of we'll send it as soon as we can being the idea, then you're only additionally introducing the latency that it takes to actually send it, process it, receive it, and start the integrations you're talking about. Yep.
Add to Matt's answer. If this kind of SLA is sufficient for you, or if this for your web server where it's always connected, you can set up something like that using our alerts and then chain them with webhooks to whatever you're talking to if you want to do some kind of operational tasks. So potentially we can have that integration with Sentry. It's relatively easy to set up.
Cool. So I threw up a QR code here for anybody that wants it, but also, and I hope you'll entertain me. Let's fly through a demo real quick, because I think slides are one thing, but like I think we all get excited about actually seeing stuff. And they're not going to kick us out yet. Thanks to everybody online for sticking around. So I wrote this one earlier. I'm just going to open it. I'm going to sit here and have you watch me typing code, given how much time we have. But let's look at this application first. So I've got I'm in my IDE of choice here, which is JetBrains Writer. I've got. Oh yes, I'm sorry. Give me 1 second. I I should be able to, I can zoom in on code. I don't know if I can zoom in here. Tool windows. Okay, yeah. This code is not important code. So I will zoom in when we've got some code. Yeah. Okay. I've got two applications running here. One is a ASP.NET Core web application using minimal APIs. And the only thing that it is doing, this is how you basically connect to Sentry in a ASP.NET Core application. So I have added to the web host that is attached to the builder that comes with the ASP.NET Core template. I've added this use Sentry command. So I've gone to NuGet and imported the Sentry.ASP.NET Core package. And every Sentry account has a DSN. This is your identifier to your particular ingestion point. And then I've done one other thing here for this demo because there's a bazillion options. You can see all the options that we have, and they're all documented and they all do different things. But there's one option that I wanted to turn on for the demo, which is this trace as sample rate. So by default, we keep a fairly low trace sample rate, so you have to opt in for traces. So I'm going to set to 1.0, which basically means there's no sampling going on at all because it's a decimal value between 0 and 1. So that way we'll get all of our tracing. And then the only other thing I have to do to integrate Sentry in the ASP.NET Core app is because of the nature of ASP.NET Core middleware, I have to also say use Sentry tracing on the app if I want to do both the APM and the errors. This part's enough to do the errors. I don't have to do anything else. But I have to add this one extra line on the app as well. Okay, so that's Sentry. And then let's see, what is this app going to do? This app is going to return an object containing my name and birthday. And let me just zoom this over. And it's going to be a little flaky. So I've introduced some randomness to this. Roughly every third try randomly, it's going to throw an exception. Boo, right? And also randomly, it's going to be slow. So randomly, it's going to be it's going to add an extra 100 to 500 milliseconds. So this isn't something you would do in a real app, of course, but you'd probably be doing your own logic, more complex things that might fail. So to me, this is a fairly reasonable demo. That's the only thing that I'm doing in the ASP.NET Core app. This is the entire app. That's it. So let's run that. Go. And yes, I know it's small. Give me a second here. I'll zoom in. Okay. So we'll just refresh a few times and oh, there, I got a boo after refreshing several times. Oh, and then it's working, and it's a little slow, and then it's working, and it's a little slower, and it's a little slower, and eventually I'll get another exception. Okay, so there's a fairly flaky service. Okay. Now let's go call that service from a Maui app. So in my Maui app, again, I added one package, which was, I'll show you the packages too, because I think that's important. On the ASP.NET Core app, it's Sentry ASP.NET Core with a package reference. On the Maui app, this is all Maui stuff off the template, but at the end of the day, all I added was package reference Sentry.Maui. Sentry.Maui is in preview. That preview tag will be dropped very soon. I can't tell you exactly when, but very soon. You're welcome to use it now and give me any feedback that you want. But I'm going to keep the preview tag on there until I know that it's not going to cause problems for you. So I added the packages, and then in the Maui app, I did a use Sentry also. And again, I'm going to keep the traces sample rate here. And I have a different DSN because they're going to go to two different projects in Sentry. And this is all I needed to add. This little bit of code here is all I needed to add to get Sentry into my Maui app. The rest of this Maui app is normal, but again, I actually want to have it do something. So I'm going to go to the main page of the application. And this is literally file new Maui. So it's got this little .NET robot that you click a button and there's a click counter. And I didn't want to take a whole lot of time to design a pretty Maui app here. So all I've done is this is code that was already there. All I've done is just added this bit on the end, which is, hey, there's my HTTP client. I'm going to call localhost. So I'm going to launch this on an Android app. And this is worth pointing out, is a lot of times when you're doing this with like a console app, you would say literally the word localhost, or you could use the IP 127.0.0.1. When you're running in an Android emulator, localhost is the actual Android device, so that doesn't work. The machine that you launch the emulator from is always on 10.0.2.2. And this is just nuances, nothing to do with anything with APM. There's one other little problem in that Android by default locks you out of anything SSL related, and that's what it's prompting me for right now. I'm going to accept that. I'm sorry, it locks you out from making untrusted connections. So if this is HTTP, not HTTPS, but development certificates are designed to be on localhost 127.0.0.1. So if you actually use this with HTTPS, the certificate's not going to line up against who it was issued against, and it's not going to let you connect. So the way you work around that in an Android app, specifically for Android, again, is you go to the Android's main the main application, and you add this little guy, use clear text traffic true. So the tag already exists, but this will put a in the generated application manifest that ends up being shipped to the device, will add a tag saying, hey, it's okay to call a regular HTTP site. And I would honestly, I would do this as like if debug around here. I'm not going to do that right now, but I would put an if debug. Otherwise, just have the regular application. Yeah, the device itself will lock you out from doing HTTP requests. It wants everything to be HTTPS. It's an Android thing. The certificate, if you did go HTTPS, is because you're now using a different IP than the one it was issued for. Excuse me, what? There is a workaround, which is to issue the certificate in a way that will be trusted by the device. And then you have to get the certificate to the device, and it takes a while to set up. So this is faster. Again, just for development, just for demo. Yeah. SSL still works. HTTPS still works. There's no magic there. It's just that you're locked out. I've been talking a lot, sorry. So that's set up. And what's it going to do? It's going to make an HTTP call, and then it's going to return the response. That's it. And I put it in a try catch. And remember I told you earlier, you might want to catch exceptions so they don't crash your application, but do something like capture that. So here's how we're actually capturing the exception that we caught. I'm also throwing it in the text so we can see it visually. And no, I don't want to breakpoint. Let me turn off that breakpoint. Okay, so we're going to run this. I think we're already running the web, so let's go run the front end. I believe it's this one on Android, on this Android Pixel device that I have right here. So here's my little Android emulator running the application, and it's going to call me that backend call, right? Now remember, it's intermittent, so sometimes it's going to work. Okay, sometimes it's going to fail. There's an error. Sometimes it's going to work. Right? Because that's what I told my backend to do. I have a flaky backend and a client UI that's calling that and having to do something. Right? So in a real app, I might actually display something to the user. Hey, sorry, we had an error. But this is just the hello world. So I've got that. I just generate a whole bunch of data, right? Blah blah blah. Okay, we've got a whole bunch of data. Let's go look at Sentry. I believe I sent that data to the projects that I created. Why am I not connected to Wi-Fi? Hold on. Yeah, it's just I did it earlier. I did it earlier and I'm not online, so I'm guessing Sentry doesn't have the data, so this will be fun to see if it will do the store and forward correctly. Okay. Now I'm in. Now let's go to Sentry. These apps are still running. That app's still running, and the backend app is still running. So in theory, I shouldn't have to do anything else. In theory, cross your fingers. I have the data I created earlier. Let's look at the Maui app. I've got multiple projects here. Where is it? .NET Maui 100, that's the one. Okay, so I've got some exceptions. These are the ones I created earlier. We'll go look under issues. Oh, sorry. Gotta make sure I'm in the right project. I'll lock it to that project. Okay, so it's not there yet. Again, we're in our eventual consistency. So I think what's happened here is Sentry has failed in sending those transactions. So it is waiting a while with its back off to try it again. One thing I can do to force it is just click it again a little bit here, now that we're online. And I should get not just the ones that we just created, but also the older ones. Come on, demo gods, work. It says 3 hours ago. Let me zoom in on this also. It should say just happened. Okay, I'm going to show you the ones that are here earlier, and later I'll figure out why my demo failed. Yeah, but I'm connected now, so it should come through. It probably will, but we're probably in a path of like try again later. So, okay, so this was a oh, look, I got an ANR. That's interesting. So the Java application actually caught that the app was hung for a little bit. That's the idea. It was hung while it was waiting, but I didn't even notice it. The user might notice, depending on the amount of the delay, but the Java application caught it. And let's look at the actual web section. Okay, so here's where I told you I couldn't connect over SSL. That's the actual exception that I got then. Clear text traffic to 10.0.0.2 not permitted. That was before I added the attribute to allow me to connect directly. So I've got the stack traces. I've got the breadcrumbs. Remember I told you, like, okay, how do we know what happened in the application? Okay, so I've added some, the application has opened some windows and added some handlers, navigated to a specific spot. These are scrolled. A button was positioned into place. If I scroll all the way to the bottom, you can see, okay, eventually the button was clicked. And all that data is available to me as the app developer to try to figure out what happened. I can also see all the things about, like, well, how much memory was available on the device. Not on my laptop, but on the virtual device that I have within. And lots and lots of other stuff, you know, the screen resolution, what versions of .NET it was. Just like knowing what versions of .NET is really useful. I can see all the different assemblies that were loaded. Like there's Microsoft Maui Essentials. There's all the system assemblies. There's some Xamarin and stuff. I don't have a lot else in this app, but if I had any third-party libraries, they would appear here as well. Let's go to the Performance tab for a minute. And let's look at all transactions. And let's look at the ASP core. Okay, so here is the GET request for that call that we're making. And you can see that transaction durations are, you know, quite long for something that small, and there's issues associated here. So I can see there's some failure rates. Over, if I zoom out here, sorry, I have to kind of zoom around a bit, but you can see there's a failure rate here. 51% of the time it's failing because I created it, I told it to. And there's also there's a little bit of variation in the request IDs because they're unique every time. But I'm using the same browser in the same environment every time here. This is all live though. And let's look at that exception. So there's the exception that was unhandled from the server. And I can, if I go at the bottom here, if I go to the top, I can see, oh, it was called by an Android device. And I can see the stack trace that it was hit at line 19. Remember, I told you the source context is missing, but that's coming soon. But I do have the file name. In this case, it's just program CS, and there wasn't a lot that was happening in this application. So it was literally just called. But if I had more information, that's where you'd see it. All the headers are here, memory info. The .NET thread pool is completely exposed to you, so you know if you're doing a lot of asynchronous concurrent stuff, you can see is it, oh, because I exhausted my thread pool, maybe I've got a lot of blocking wait calls, for example, if I've done async await wrong, that would show up there. Lots and lots of other information. So all this is super useful as a developer to be like, what's going on here? I don't actually even need the live code to figure it out. I can click this. Oops, right clicked, and I can see that this event was part of a transaction summary, right? So where is the trace? I want to show you the trace. Give me a second to find it. It should just be right here, view full trace. Okay, so here we can see the trace was, this is just showing the GET request. Well, I have another bug here. Thanks for having me demo this. Now I can show you my bugs, because what this should have shown above it was the actual, on the Maui side, it should have shown the Maui application starting the trace header. Although it's possible this is the one that I kicked off when I just loaded the browser. I'm not sure. That's why I wanted to start from the Maui side, because that would definitely show me. Okay, so that's not there yet, but it'll come. Oh, I know why. So I created the Maui application, and I wired it to Sentry, but I did not set up tracing in the Maui application, because at the moment in preview, Sentry doesn't have automatic tracing for Maui, but you could manually trace. You could start a transaction before making that request. Let's go do that real quick. I think that'll be fun. If people are good on time. Not Visual Studio, sorry, I want my writer application. Let's just, before we make this request, let's go here and say Sentry SDK dot start transaction. And we're going to call it something, web request. And we need to give it an operation name too. Foo. It is. I'm not sure if it's disposable, but we have to finish it. No, it's not disposable. So I go down here, and then when we're done, we would say transaction.finish. And by default, it's just OK. If we have an exception, we're going to say transaction.finish with an error. We're going to say, there's a lot of stuff here, internal error, good enough. And actually, I want to move it one level up so that I can catch it here as well. Yeah. So ideally, this would have been done for us. But at least this will start a transaction. Oh, and there's another thing we can do. You are all getting to watch me live program, lovely. When we add the HTTP client, I believe it's here. Is it here? Okay, I'll have to look for this later. I'm not going to bore you all to death. But ideally, what I would do is I would say new Sentry HTTP message handler, and I would pass that into the HTTP client. I don't know the syntax off the top of my head. But anyway, this should at least get us a transaction started. I need to reload it. I suppose without the message handler, it's not going to link the two transactions. So we're not going to get the full distributed trace, but at least we'll see a transaction on the Maui side. Oops, we're in here. Did it launch? Yeah, this is the new one. So we're running now. These are creating transactions, sending data off to Sentry. And now when I go look at performance, and here's where we're going to kind of see what the latency is like here, because they should come in. No, we don't have it outdated. It's because we're in preview. Come on, data.
Where's that data stored?
So locally, it's stored on the device in memory, and then it is written to the storage system, the read-write temp storage system on the device, as it's cached in case it needs to store and forward. And it's read back out of there as it's sent back to Sentry.
Is it stored locally in a flat file?
No. Once it gets sent off to Sentry, it's part of the Sentry database on the back end.
Does it use an open source database?
Yeah, yeah. It's using so like I said, you can run Sentry completely open source. You can host it on your own, and it'll come with a Docker container. It uses a few different databases, and I don't work on the backend architecture, but I know that it uses for time series data. It uses a thing called ClickHouse. And we have a open source product that runs on top of ClickHouse called Snuba. So some of this data is very time dependent in order to get the graphs out. So it's not just sitting in a flat file. I really don't know what I've done wrong. I've done something wrong. Maybe I'm looking at the wrong account or something.
Did you say the Maui app was on a different account than backend app?
Yeah, but I'm looking at the Maui app. I'm looking at the Maui app right now. Demo got struck again. This worked earlier today. Well, it would have come through like this, and we would have seen a bunch of transactions. Let's cheat just one little bit, but then I think we're going to call it done. One thing you can do, if you want to play with Sentry, I don't want to go here, sorry. If you don't have an account and you go to Sentry, I have to say /welcome because I do have an account. But at the top, you'll get this screen by default if you just come into Sentry. And there's this link at the top that says Sandbox. So you can click on the Sentry Sandbox. And what this is like, it's got a whole bunch of projects and a whole bunch of languages. And roughly every half hour, I think, half an hour to an hour, it gets refreshed. So there's a lot of data in here that you can just like play with Sentry, and you can screw everything up, and then it'll just all get deleted and recreated. So it's a really good place to just like see what works. I think earlier I showed you guys the distributed trace with this Unity game. This came from this bug. So like I've got a HTTP 500. So this is just our thing here. And if I look at the full trace here, this is what I wanted to see for the Maui app, is that, hey, it's this bug started in Unity in this case, and then wound up on this Google Cloud function. So I can click the Google Cloud functions transaction, says, hey, an error occurred. Let's see the error. And I get back to the HTTP request. And on the front end, I could see, oh, there was an error, and I've got the 500. Right? So the error occurred both on the back end and on the front end because they're dependent upon each other. And I can see exactly what part of the game that I was in, again, with the breadcrumbs. Looks like the game was, state was upgrading, and we went to a fighting state, whatever that is. And there was something about a shader. I'm not a game developer, so. Oh, and look, it's running on a Mac. So you can see that. I think it says right at the top, or is it running in iOS? It's running on iOS, on an Apple A13 GPU. But I think you get the point. And I'll go back and figure out later why the demo didn't work exactly right. But ideally, whether it's .NET or Python or JavaScript, or you're running a blend of all these, which many, many people are, different front ends and different back ends, if you instrument your app correctly, again, think of those 4 pillars. So yeah, you got to be thinking about systems monitoring. You got to be thinking about logging. You got to be thinking about APM, and you need to be thinking about error monitoring. And many tools will provide one or more of those, not just a single one. If all you're doing is logging, then you're going to be spending a lot of time sifting through your logs and not getting this level of detail, which is really useful in order to actually fix the bugs. So I think I will end it there. Do you have a question?
Yeah, can you correlate the traces with logging? Or is there a logging component?
Yes.
to this?
Yes, so logging helps with breadcrumbs. So like in this case, actually this is a great example because right there is the Unity built-in logger that is part of, this is a game engine I'm looking at, so it's got a logger and it logged this message get state, game state upgrading. So it logged it at the info level, logging uses log levels, info, warning, error, critical. And because it's logging the info level, well, by default, we wouldn't want to send every information bit as an error, right? It's not necessarily an error. But if an error occurs, then it's good information to have. So that's why it's showing up as a breadcrumb here. Does that make sense? So if you just said, another way you can do logging, by the way, in .NET, you can use an iLogger, right? So if we were in, let me go to, well, I'm in a minimal logger, but let's just say I had an iLogger. I'd have to get this wired up correctly, which I'm not going to do right now. But there's a console logger on here. I don't even have the console logger on here because I'd have to import it. But let's just say I had that. So I could say logger.log and something, anything at log level debug, for example, or here, because we want it to show up, right? So if I said error and log something, then in theory, if that logger was created correctly, then that would throw an error. Because Sentry would pick up and say, oh, you're using a logger, and at warning or error state, I'm going to send that additional information to Sentry. Or at error critical state, I'll create an error out of it at warning and below, then they become breadcrumbs. The other thing you could do if you didn't want to work with that interface is you could say Sentry SDK .log message. Capture message, sorry, which is just pretty much the same thing, foo and a level, right? Error, fatal, warning. Let's say Sentry level fatal, whatever, that would be pretty bad. So I would do that like right before my application is completely crashing. It does bring up an interesting point though. Your application is completely crashed, so how does that message get sent anywhere, right? Well, almost always just before that crashes a split second to do something, and we won't even try to send to Sentry. What we do is write it to disk. Because most of the time when your app crashes, you're like, why did that crash? Did you open the app again? Error sitting on disk. We note that the app crashed because also when your app started, we marked a little flag on disk saying the app started, so the flag is still there, it didn't get cleared right. And we can tell that was an unhealthy session. We grab anything that was written, and we can send that off as a crash. So even like a flat out, I yank the power on my machine, we can capture those things. Other questions? Yes. A few different things with regard to OpenTelemetry. So Sentry started well before OpenTelemetry was a thing, so understand that. We are mostly aligned on many concepts. So for the most part, they're compatible. The major difference is what I called out earlier, in that we have this concept of transaction where OpenTelemetry just calls that another span. That does make some minor nuances in how things work, but generally speaking, they're compatible. We support the W3C baggage header in most of our applications, which is SDKs, which is part of the OpenTelemetry way of passing data around. And the different SDKs are just recently, in the last few months, starting to get support for OpenTelemetry. And when I say support for OpenTelemetry, what I mean is if you're using Sentry and things that are instrumented with OpenTelemetry, you don't have to do anything else. We'll bridge the data from the OpenTelemetry instrumentation library into the Sentry collector that's built into the Sentry SDK. Yes. Yes. You can. So there's also, separately from all of that, there are Sentry exporters for OpenTelemetry that are already part of the OpenTelemetry repositories. It's not how it's typically done, though. Most of our customers have been saying, my understanding is most of our customers have been saying that they like Sentry and they just want all the benefits that OpenTelemetry adds. So they don't want to wait for example, they don't want to wait for me and my small Sentry.net team to go around to write a Redis client for Sentry, right? Or Redis integrate. We would have to learn about how data is exposed in Redis, specifically the Stack Exchange.Redis client that everybody uses to talk to Redis. So if you're talking to Redis, you're probably using that client. It has an OpenTelemetry plugin. So rather than waiting for Sentry to say, I support that client, you grab the OpenTelemetry client, you're already using Sentry, and everything just works. I didn't get too far into metrics other than as part of APM. Mostly, we think about Sentry as a for developers product. So if you're thinking about metrics in terms of operational metrics, again, like how many nodes am I running, how many servers am I running, do I need to scale out, et cetera. Yeah, you can do that with, I can do that right here. So we can say Sentry SDK dot capture, no, it's, give me a second, it's new. We call them measurements. Is it capture measurement? Why can't I find it? I have to look it up. Sorry, I don't know it off the top of my head. But there is a API for custom measurements in Sentry.net, and indeed it would capture metrics. So you could say I have 3 of these things or whatever. Give me a second to. I'm going to just look on GitHub at our lovely little change log, and we have custom measurements API. There it is. Yep. So, oh, it's because it's on a transaction. That makes sense. Measurements are part of transactions. So that's the API right there. So you say you would say start transaction. I get that transaction object that I had earlier, and from there you say set measurement, and you can give it a name, a value, and a unit. So even if it's inches, I think that's in there somewhere. But chances are it's going to be time or data or a custom unit. Yeah, how would I add context? You can literally say, yeah, so you can say when you configure you would configure a scope and say this context applies context. Here it is. So we have lots of them already. And we have one called user. There, somewhere here. App runtime. We should have user. Maybe it's under one of the other ones. Is it app dot? Yeah, this would be something that we would probably pick up for you. This is the app name. Yeah, it's basically a dictionary with some predefined keys, and you can add whatever you want to it. I thought user was top level. No, I'm confused. Yeah. Right. So at the end of the day, you could add a custom user object, but it would need to be serializable. Chances are you're probably going to add a user ID or an email address or a name, and that's what would end up as part of the user context, and it would show up in context on the transaction. And I do believe it does go in the baggage header. Yeah, if I remember right. Other questions?
IoT devices.
IoT devices. Can we run Sentry on IoT devices? Yeah, probably. Let me know how it goes. I think so. I think so because at the end of the day, the Sentry SDKs for .NET, if I go to NuGet, I think this is the best view. And I type in, for example, we've been talking about Maui a lot, so I'll put in Sentry Maui, and there it is. And let's just look at its dependencies. So Sentry Maui is dependent on another library called Sentry Extensions Logging. which is a plugin for Microsoft extensions logging. So that's just where we have decided to put anything that calls an iLogger to add breadcrumbs comes out of that package. But it is dependent upon the Sentry package, which is the bulk of what Sentry has for .NET. You can, on any .NET type that is supported by any of these frameworks, so going back to .NET Standard 2.0, .NET Framework 4.6.1, .NET Core, we target a 3.0 here, but you could run it on 2.0 because of the not a Standard 2.0. Anything that's compatible with any of this, you could probably just take the Sentry NuGet package, if you can reference the NuGet package, and it would probably work. What you don't always get, though, are all of the integrations. So we have a Sentry ASP.NET Core integration because we have middleware that's ASP.NET Core middleware that understands how to talk to the request pipeline, right? We have Sentry MAUI integration because it understands how to work with the native SDKs that need to be on the MAUI device in order to capture all that information. So in an IoT world, we wouldn't have any of that stuff. You'd be left with generic unhandled exceptions that would be thrown through, assuming they're thrown app domain unhandled exception handler, which from experience, that happens in most .NET environments. But like, for example, on MAUI, we had to write our own workaround for WinUI 3 because it doesn't use that. It uses its own thing. So I don't know, maybe you're using Nano Framework or one of these other IoT platforms. They may have their own way of like throwing a top level unhandled exception. If they do, you'd want to attach to that event, and within that event, say Sentry SDK capture exception. They may also have their own, you may have your own concept of what a transaction means in that environment, and it may be very specific to what that device does. Maybe a doorbell, pushing the button, ringing the buzzer is a transaction. So we wouldn't have any way to instrument that because we don't know, right? Does that answer your question? Yeah, try it, please. Let us know. And if you run into any problems, like I said, Sentry is completely open source, and we're very transparent about all the work we do. So you can raise an issue on GitHub. We have a Discord channel. You can come talk to us anytime. If you actually had something, that you really needed to show me, I'd probably just get on a virtual call with you and we talk about it. But we're pretty easy in that way. Why Sentry instead of OTel and Elk? Yeah. I don't know. There are preferences for a lot of things. I guess it's a very opinionated question. There are a lot of different providers. Like I said, why Sentry instead of App Insights, right? Yeah. So my real message to you all is do application monitoring and be thinking about all 4 pillars. I happen to work at Sentry, and I think it's a great product because it's open source, so you can go and run with it for free. The OTel and Elk story is also, there's probably more configuration. I haven't set that up myself specifically. There's probably a lot more to do to manage to get that working correctly. And my understanding is that you're still in a very performance monitoring trace world, and you're not really necessarily thinking about errors in the same way. And they're not necessarily linking everything together in the same way. So you may know that something took longer, and you may know that it was called through this series of events, but you may not know the amount of memory on that device that happened to be running this version of iPhone all the way down to the context of what was happening in the error that occurred on the back end that called the database. So it's kind of more of a complete picture thing. Does that make sense?
Is there an API to Sentry so you can take its events and put them in your own?
Yes. Yes, Sentry has APIs. You can absolutely call and export through REST or GraphQL. There are APIs for that, and there are also integrations and plugins. And like if you want Sentry to alert you in a Slack channel, it can do that, for example. All right, I think we're about out of time. Thanks again for anybody who hung out online. Are there questions online?
Nothing
Okay. All right. I believe if you either scan this QR code or go to, I don't know how we got just .NET-survey, bit.ly.net/survey, we'll give away some swag and not pester you too much. So.
Yes, that's right. And if you fill that out on accident when you came in, because we accidentally had the wrong one up at the beginning, you don't need to fill it out again, unless you filled out something wrong, in which case, do fill it out again.
All right. Thank you very much. Hope this was helpful. Somebody needs to end the live stream. Bye.